All right then, we'll give this a try. See if I can get this to work right this time. Question I had on worksheet D. Sorry, forces and laws of motion, problem D, dealing with coefficients of friction. Okay, the example problem. A 20 kilogram trunk is pushed along the floor of a moving van by a horizontal force. If the coefficient of kinetic friction between the trunk and the floor is 0.255, what is the magnitude of the frictional force opposing the applied force? Okay, so things we know. We have a mass, and that's 20 kilograms, 3 sig figs there. You have a coefficient of kinetic friction. This only applies when it's moving. If it's static friction, it hasn't moved yet. Is 0.255. We know that gravity, little g, the magnitude of the acceleration due to gravity is 9.81. And that is in meters per second squared. There is no unit for the coefficient of friction. It's a unitless measure. We want to find the force of kinetic friction. Okay, the formula for the force of kinetic friction is F sub k equals mu sub k times the normal force. So, we have an object. It's a trunk. It's moving across the floor of a van by some sort of horizontal force. Okay? We want to find the magnitude of the resisting force. So, I like to start from a free body diagram. I like pictures. We know we have a normal force acting upward. That's applied by the floor on the box. We have a force due to gravity acting downwards. Okay, remember with the free body diagrams, the shape represents the object, and everything we say is acting on the middle, the center of mass. Then we have a force of a push. Which direction? Don't know. So I'm just going to draw it forward. This is the force due to the push. Then there is an opposing force. Remember, frictional forces, drags, all of those things are always in the opposite direction of the motion. Always. So we have a force of kinetic friction. What does that mean? We know it's moving. Okay, if it's not moving, then we're dealing with static friction. Okay, so we have this. What do we know? Well, I like to look at the sum of the forces in each direction. Some of the forces in the y direction are 0. How do we know that? It is not moving up or down. It is not accelerating, up or down. If there is no acceleration in the vertical direction, then the sum of the forces in the y direction are 0. Well, this equals then the normal force minus the force due to gravity. We know then, because this equals 0, we know the normal force in this case is simply equal to the force due to gravity, which is simply mg. That is the normal force. Some of the forces in the x direction, we don't know. We don't know if it's accelerating or not. We simply know that it is moving. So this isn't going to help us a whole lot in this situation because we don't know. But we still want to find the frictional force, the coefficient of kinetic friction. Since we can't find it from the sum of the forces in the x direction, which would be the other way we would be able to do it. If we knew what the net acceleration was, if we knew what the applied force was, we could solve from this. But we don't know. We don't know what the force of the push is. We're trying to find the force of kinetic friction. If it was not accelerating, if it was simply moving with a constant velocity, that would be equal to 0. And we could maybe solve. If I knew this, then I would know that. If I knew what the overall acceleration was, I could figure that out in the x direction. I could figure out what the force of kinetic friction was, assuming I knew this. But again, we don't, so this doesn't really get us anywhere. So we're going to have to go back to this formula to find the force of kinetic friction. Do we have enough to figure this out? Well, yes, we do. We know what the normal force is. We know what the coefficient of kinetic friction is. So this becomes a simple formula, that the force of kinetic friction, its magnitude, again, I'm not treating these as vectors at the moment, this is simply magnitude, is going to equal mu sub k F sub n. This will equal 0.255 times, well, the mass of the object, because remember, F sub n, simply in this case, is equal to mg. Well, it's equal to mg, so that's going to be my 20 kilograms times then 9.81. If you put that into your calculator correctly, I believe you get 50.031 newtons. How many significant digits should this answer have? Well, it should only have 3. I have 3 here, 3 here, 3 here. The rule when I multiply or divide is the least number of significant digits. Well, it's 3, so I'm going to round this to 3, which means I'm rounding to the tenths place for significant figures. That means my answer should be 50.0 newtons. And that is how the example problem should be done. Okay, I'm still working on getting this whole video thing down. So I'm going to try this and send it out hopefully to my site that I'm forming and see if I can get it to work. If it does, we'll have more stuff upcoming. So, ladies and gentlemen, boys and girls, fellow Homo sapiens, thank you for your time. And remember, drive fast, take chances, do inappropriate things with people your own age. Thank you.